Good afternoon, good evening, and very warm welcome to the session. Yes, so this is one of the most favorite sessions of most of you. Yeah, and everybody is curious to learn about the numericals that usually come for our CSIR NET examination. Yes, right. So as far as our life science is considered, majority of us usually get scared for the numericals. But actually it is not needed. Okay, so you should not get scared by way of numericals, because numericals are simple questions. They are very direct. I hope that I am visible and audible, right? Yes, everybody can see me. All right. Yes, Kunal. Okay, so definitely all these numericals, they are the boosters, because very good you can score well for your paper. Okay, yes, this is the scoring things. Okay, so this is a little bit about me. Yes, so if at all you are watching me for the first time, I am Dr. Saranya. I have completed my Ph.D. in tissue engineering. So this is my profile set. Yes, Kunal, I am great. How are you? Nice to know that. Okay, fine, everybody. Come on. So these are my papers to the credit. Yes, just for your inspiration. Okay. So the first formula that we are going to see today, it is about your Hardy-Weinberg equilibrium. To begin with, I have just put a simple formula. Okay, right. And this is containing two parts. Okay, so number one, it is your routine formula, P plus Q is equal to 1, and it is applicable for your allelic frequency. Okay, so for allelic frequency, good Kunal. So for the allelic frequency, which one you will use? You will use the formula P plus Q is equal to 1. Okay, right. And the same, whenever it is being asked for the genotypic frequency. Yeah, if it is going to be for the genotypic frequency, you have to use the formula P square plus 2PQ plus Q square. Right? Fine. So let us take a question. The frequency of the alleles, which is going to be A and A, it is going to be present in a population at Hardy-Weinberg equilibrium. So what is the allelic frequency? This is the allele frequency of the allele. So they have given the allelic frequency. Okay. So allelic frequency, they have given it as 0.3 and 0.7. So is it P or P squared? Yes, this is P and Q, or P squared and Q squared. This is where majority of the students, they get struck, right? 0.3 and 0.7, it is P and Q, or it is P squared and Q squared. Think and you can give the answer in the comment box. Yes, Ram, exactly. This is going to be P and Q, because it is for the, yes, Kunal, correct. It is for your allelic frequency. So it is going to be your P and Q. So P is 0.7, Q is 0.3. Yes, Abhay, very good. So Q is 0.3. Now how many it is heterozygotes? So heterozygotes, yes, Ram, correct. It is going to be 2 into P into Q. This is the thing for your heterozygotes. Just do it with me. If at all you know it, you can do. If not, just you can do it with me. Don't worry. Yes. Very good, Swati Priya. Yes, Kunal, Ramprabha. Come on. So 2 into P is going to be 0.7 and Q it is going to be 0.3. Okay. So 0.21 into 2 it is equal to 0.42. So what is this 2PQ? 2PQ it is equal to 0.42. So how many individuals are there? 250 are there. So what you have to do is that you have to multiply this 250 with this 42. Okay. So 250 into 0.42. It is going to give you 105. Right. So that is going to be the correct answer for this question. Got it? Okay. So the only crux, okay, it is identification of this as P and this as Q. By chance, if you have taken it as P squared, that's all. It will be highly misleading. This is where majority of the students get tricked with the Hardy-Weinberg equilibrium problems. It will look very simple from outside. Okay, but seriously, when you are practicing only, you will experience where you get twisted and turned between this P and Q as well as P squared and Q squared. So be clear, always P, it is representing the allelic frequency, and this P squared, it is called as genotypic frequency, or it is called as a genetic frequency. So now you understood the difference. Fantastic. So this is how you have to do the problem. Okay, right. And this is another simple problem. Consider a single locus with two alleles which are at Hardy-Weinberg equilibrium. If the frequency of one of the homozygous genotype, it is 0.64. What is the frequency of heterozygotes in the population? Now what is given? P is given or P squared is given? Think and tell me. In this question, very good Ram. In this question, P is given or P squared is given? What is given in the question? Did you get my point now? Very good. Yes, Kunal. Yes, Ram Prabha. Right. So everybody else, don't worry. Here they have given the genotype. Genotype means you have to use the second formula. Okay. If it is going to be allelic, then only it is going to be the first formula P squared, P plus Q. If it is going to be genotypic, it is P squared. So what is P squared? It is 0.64. So what should be P? Square root of 0.64 is 0.8. What is Q? 0.2. So heterozygote is 2 into P into Q. So 2 into 0.8 into 0.2. So that becomes 0.32. Got it? So now this is clear how to identify whether it is genotypic frequency or it is going to be your allelic frequency. P and Q, and then P squared and Q squared. Now the problem is resolved. Okay. So the second major numerical that our CSIR NET will ask, it is from the methodology by using the absorbance. Okay. So this absorbance, by using your spectroscopy, they usually ask from this formula A, it is equal to epsilon Cl. Okay, right. And what is going to be this A? We all know that. Yes, Melina, Sushita. Nice. A is going to be the absorbance. And what is epsilon? Saying it a long time, Sushita. Yeah, epsilon, it is going to be the molecular, yes, Abhay. Molecular extinction coefficient. Okay. Yeah, so this epsilon, it is a constant actually. It is a molecular extinction coefficient. C, it is going to be the concentration. L, it is going to be the path length. What is L? L, it is going to be the path length. Okay. So absorbance is equal to epsilon Cl. Epsilon is the molecular extinction coefficient. C is the concentration. L is the path length. That's all you need to know. One more important component you need to know, that is the unit. Okay, units are very, very important. As far as the path length is considered, its standard unit is centimeter. Okay, so what is the standard unit for the path length? It is going to be the centimeter. And what is the unit for your concentration? It is going to be in the moles. Okay, mole per liter. Okay, right. This doesn't have any unit. So epsilon doesn't have any unit. Okay, so this is the total formula. Okay, so it is mole per liter. What about your milliliter? It is mole per ml. Okay, if it is going to be ml, how you can take this molarity? It should be millimolar. Got it? Yes. If it is mu L, it should be micromolar. That's all. Understood this logic? This is very, very important. Not only in this problem, but in every problem like this only it will be asked. Okay. So you have to always remember this correlation. Okay. So when it is going to be in this molar, it is per liter. Okay, when it is going to be milliliter, sorry, oh my god, gone totally. Just a moment. Right? It is not coming up. Just a moment. Okay, so if it is mole, it is per liter. If it is millimole, it should be in ml. If it is going to be micromole, it should be in microliter. This one, please never ever miss the table. Alright. So is it now clear to you? Yes? Absolutely. Fine. Fantastic. So now let us take up with the problem. Everybody is ready for the problem? Alright. So a protein. Okay. So a protein is present which has one tryptophan and one tyrosine residue. Okay. In its sequence. Right. Assume that this molar extinction coefficient at your 280 nanometer of tryptophan and tyrosine. So this is the epsilon of tryptophan. It is 3000 and epsilon of tyrosine, it is 1500. So you have only one tryptophan and one tyrosine residue. Okay, right, fine. And see the unit, it is going to be m-1 centimeter -1. Okay, so it means that you have to take them in m. Okay, so what would be the molar concentration of the protein if its absorption is going to be 0.90? Got it? Come on everybody, try it out, try it out. Everybody in the class should try this problem. Very, very important problem for you all. Come on everyone. So unit conversion is very, very important. You know the answer that is different, but you have to convert them into the correct unit. Got it? Come on all. Make it fast, make it fast. Yes. So you all know that absorbance is equal to epsilon into C into L. Is epsilon given? Individual amino acids they have given. Right? So think what should be the total molecular extinction coefficient. Yes, Kunal, I'll wait. In a moment, I'll have a cup of water in the meanwhile. Think everyone. Yes. Yes, Kunal, got it? What about others? So what is going to be your total epsilon? The epsilon is going to be 4500. Absorbance, it is given in the question as 0.9. It is equal to epsilon. Yes, Kunal, you are 4500 into C into 1 centimeter. Okay, so if it is not given, it is absolutely going to be taken as 1. Okay, right, fine. So now, yes, Chakra, yeah, Shushita, yeah, Shwati, correct. Everybody is right. So now what is going to be the C? C is equal to 0.9 divided by 4500. This will be in M, correct? Yeah. But now if you want to divide it, it is going to become like 9 divided by yes, 45,000. So you have to convert it into millimolar. You can take it as one more 3. Okay, so this 3 and this 3 will be cut off, right? So it is going to be like 1 by 5. So that is going to be your 0.2. So it is millimolar. So 0.2 millimolar is going to be the correct answer for this question. Everybody in the class, did you get this conversion? This is very, very important. So for the sake of new ones, I am repeating it slowly one more time. Yes, I know that old ones, you will all be a pro player in this. But for the ones who are watching it for the first time, I am slowly explaining it one more time. So the formula is absorbance is equal to epsilon into C into L. So A, it is going to be the absorbance. Absorbance has no unit. Okay, epsilon, it also has no unit. Concentration must be in moles and path length should be in centimeter. So this fellow, it is going to be m minus 1 centimeter minus 1, but it is a constant. So that is why if you take epsilon into C into L, this m minus 1 and m get cancelled. This em minus 1 and this em will get cancelled, and absorbance has no unit. It is just an integer. Okay, right. So here in this problem, they have given that A is going to be 0.9. Epsilon, they have given it like, what is that? 3000 plus 1500. So what is the total number? Sum them up. It is 4500. C, it is the question. L, if it is not given, you have to take it as 1 centimeter. So 0.9, it is equal to epsilon into C. L, no, it is 1. So I am just leaving it. So what is C? C, it is equal to 0.9 divided by 4500. What is the standard unit for C? It is going to be in moles. Okay, right. So now this is very small number. So I am converting it into millimoles. So if I convert it into millimoles, I can multiply it by 1000, isn't it? Yeah. So when I am converting my 1 mole, it is equal to 1000 millimole. Okay. So I am going from big to small. If I have 100 rupees, I can buy 100 1 rupee coins, isn't it? Yes. So from higher unit, if you are going, you have to multiply. If you are going from lower unit to higher unit, you have to divide. So this is the basic. Okay. So I am multiplying it by 10 by 3. Okay, so this I am just rewriting 9 divided by 45, one more 0 I am just putting, into 10 power 3. So 10 power 3 and this gets cancelled. So it is 9 by 45, so that is 1 by 5 millimoles. So 1 by 5 is nothing but 0.2 millimoles. Now everybody in the class got this, how we got this answer? All of you are clear in this aspect now? So everybody can understand this, I guess. Yes? Fantastic, everybody. Keep it up. So now we are coming to a biochemistry question. How many asymmetric carbon? Yes, Abhay, yes, Ram, yes, Kunal. How many, yes, PLE. How many asymmetric carbon atoms it is present in the compound whose structure is as follows? Okay, right. So they have given it. You are going to find out how many asymmetric carbon atoms are present in this molecule. What is asymmetric? Asymmetric means all the 4 groups must be different. If all the 4 groups are different, then only you call it as an asymmetric. Okay. So in this molecule, how many asymmetric carbon atoms are there? Yes, Kunal, Ram Prabha, Shwati, PLE. Very good, everybody. So there are going to be 4 atoms. In general, for the carbohydrates, we have a rule where we can eliminate your CHO or C double bond O group, functional group, and the CH2OH group. Apart from that, whatever is remaining, it becomes the number of achiral atoms. So if it is 6, 6 minus 2, 4. If it is a heptamer, how many asymmetrical carbon atoms will be there for our carbohydrates? So it becomes 7 minus 2. So 5. Got it? So now you understood how to calculate for your carbohydrates. Just minus 2. So this is totally 6. So 6 minus 2 is 4. If it is going to be 7, it will become like 7 minus 2. It is going to be your 5. Understood? Right. So now you are going to tell me how many stereoisomers can be formed. How many stereoisomers can be formed from this? You have to use the formula 2 power n. Very good. So it is 2 power 4. So 2 into 2 into 2 into 2. So it is 16. So 16 should be the answer if they are asking the number of stereoisomers. Yes, Ramprabha, it is going to be 2 power n. N is equal to 4. So it becomes 2 power 4. So that is equal to 16. Yes, PLE. Yes, Ramprabha, Kunal. Very good. Fine. So this AT and GC ratio in a newly discovered organism, it is going to be, yes, PLE, 0.63. Okay, so this AT, it is going to be 0.63. Yes, and GC, it is going to be 0.8. Okay, right. So what is going to be the genome of this organism? It is single-stranded. It is going to be double-stranded. Single-stranded RNA, double-stranded RNA. First, eliminate the unwanted options. Definitely, you can come up with the correct answer. Am I right? Good, everybody. Definitely AT is there. So it is not an RNA, isn't it? So now you have a doubt whether it is going to be a single-stranded DNA or double-stranded DNA. If it is going to be double-stranded DNA, what is the rule? Your AT plus GC should be equal to 1, isn't it? So this is not equal to 1. So that means that it is not a double standard. It is not obeying your Chargaff rule. Yeah, so Chargaff rule is disobeyed. That means definitely it is not going to be a double standard DNA. If it is not a double standard DNA, bright chances are there that it is going to be your single standard DNA. Yes, Ramakrishna, correct. It is going to be a single standard DNA. So one more question, shall we take it up of similar trend? This is from molecular biology. For a double-stranded DNA, which one of the following base ratios will always be equal to 1? Good. Quite an interesting question, isn't it? Yes, it is the Chargaff rule. Yes, Mohit. Yes, Suchita, Ramprabha, Abhay. Let us check. Let us check this. Come on. I am taking A as 20. What should be T? If A is 20, what should be T? Our eyes are wrong. This is where majority of the aspirants will tremble. Now tell me what should be T. If A is 20, T should also be 20. Everybody agree with that? Okay. If this is so, what should be your G plus C? A plus T is 40. So G plus C should be 60. If G plus C is 60, G should be 30. C should be 30. Now tell me which formula is correct. Yes, Shwati. Yes, Mohit. Yes, Kunal. Piyali. Ramprabha. Now tell me which formula is correct. Yes. Got the point? Yes, Ramprabha. So, your A plus G divided by C plus T, this can only be equal to 1. What is A plus T? Yes, Kunal. A plus T is 40. G plus C is 60. It can never be equal to 1 based on the Chargaff rule. But what happens? Usually we all have a misconception of this formula A plus T by G plus C. Never. Okay. It is going to be A plus G. Yes, Piyali. Yeah, Kunal, I saw it. Good. So A plus G by C plus T, it is equal to 1 must be the right answer. Now all of you got it? Yeah, that is what. So these are the numericals which we have been doing so long, but still we will get tricked. Okay, so how you can resolve it? As far as our CSIR is concerned, we have quite time for answering every question. Just take a sample like how I did. A is 20, T is 20, G is 30, G is 30. Like that if you do and see, any question you will never go wrong. Okay, just you take a value on your own and test the formula and then give the answer. Got it? Yes? Fantastic. Okay. So, if at all the nucleotides, okay, they have the equal probability of occurrence in a 4 megabase pair long DNA sequence, then how many times will the site of EcoR1 restriction endonuclease occur? Do you know what is this sequence of your EcoR1 restriction endonuclease? You could have studied that. EcoR1 is GAA TTC, isn't it? Right? Yes. So now you are going to tell me what is the probability of occurrence of how many times this EcoR1 site will occur in 4 megabase pair long DNA. Understood? Everybody in the class? Come on, guys. Yes. Come on, what should be the answer for this question then? You want time to think? I'll give, don't worry. Yes, I should give you time for this question. Yes. Done? All of you in the class, you are done? Shall we discuss? Okay, time's up. Okay, let us see, don't worry. Okay, yeah, it is going to be obviously A, 976. We do have approximation, you may be thinking of D, but actually it is precisely A. Okay, so yeah, obviously. So like what we have to do is that we have to look at the options. See, this option A and D are very close. So do not use any approximation. So let us learn like how to solve this problem. Yes, Payali, it is right. Yes, good. So what happens? Yeah, it is telling about the frequency of cutting. Okay, right. So how many bases are there? How many bases are there? 4 bases, isn't it? Yes, yes, correct. It is GAATTC. So for that you have every base, isn't it? Right. So base is 4, correct? So it is becoming 4 power n. It is the possible number. Okay, once in every 4 power n it is going to come. Right. So as far as, and what is n now? N is the number, isn't it? So what is n now? 1, 2, 3, 4, 5, 6. So I usually used to give a formula like base to the power mer. So what is the base? 4 bases are there. What mer it is? 6 mer it is. So 4 to the power 6. Okay, right. So 4 to the power 6 is nothing but it is going to be 4096 bases. So 4 to the power 6 is going to be 4096 bases. So if it is going to be a 4 mega base pair, so mega means you can multiply it by 10 power 6, right? So the total sequence length is 4 into 10 to the power 6 divided by 4096. So it cannot be 1000. It is little bit lesser than 1000. So 976 is going to be the correct answer for this question. Got it? Same formula. This formula I could have taught you several times. Base to the power mer, isn't it? So now you remember this and where to apply this formula, base to the power mer. Yeah? It is all damn clear to you? Yes. Alright. Good. So without enzyme kinetics, how we can do the numericals? Isn't it? Okay. So let us see this enzyme kinetics numerical. Okay. So an enzyme, it is going to follow your kinetics. Okay. So what your enzyme is going to follow? It is going to follow your kinetics. Okay. Right. So it is catalyzing the conversion of 35 micromolar of your substrate into the product with a reaction velocity of 10 micromole per second. The Km and the Kcat they have given. Now they are asking the total enzyme that is taken for the reaction. So two formulas we have to use. One is Km. Km you have to find out by using your equation. And next you have to know the relation between your Kcat, E and Vmax. Only two formulas to solve this question. Everybody give a try for this question. First you tell me what is your V. V is equal to Vmax into S by S plus Km. This is your equation. Is this all thorough to you? Okay. And what is going to be your Kcat? E into Vmax or E by Vmax? What is your Kcat? E into Vmax or E by Vmax? Quick. Think. E into Vmax. Everybody agree that it is E into Vmax? So what is your Kcat value? Kcat value is E into Vmax. Correct only. It is E into Vmax. So what is your Vmax? E by Vmax. Think, check it once. Yeah, absolutely. So correct. E divided by Vmax. So here we are multiplying. Yes, correct. Your Kcat is equal to your Kcat is equal to Vmax by E and the reverse way. Yes, your Kcat is equal to Vmax by E. Correct. Sorry. So your K cat is equal to V max divided by E. Okay. Right. Yes. So E into K cat is equal to V max. Okay. So if you want your K cat alone, your K cat is equal to V max by E. Okay. Yes. Okay. So your K cat is equal to V max by E. So now you substitute and you can find out the answer. Yes or no? So here in the question they have given the K cat. What is the K cat? 500. You know the V max? This is the question. You know the V max? You don't know the V max. But do you know the V? So you know yes, you know V. What is V? 10 micromole. It is equal to V max, you don't know, into S. S is going to be 35 micromole divided by S, again 35 micromole, plus Km. What is Km? 14. Right. So it is going to be like 49. Correct, no? S plus Km is 49. So there is 35 V max. It is equal to 10. Right. So it is like 490 is equal to 35 into V max. So V max is equal to 490 divided by 35. So what is the answer? 490 by 35. Come on everybody. It is coming around 14 for you all. Yes or no? You are all there or what? It is going to be 14. Everybody is getting 14? So what is this 14? 14 is going to be your V max. So what is going to be your K cat? K cat is 500. Okay, so K cat is equal to V max by E. Yes, and K cat is going to be 500. V max is 14. So what is your E? E is equal to 14 divided by 500. Yes. Come on everybody. Did you get it? Yeah? 14 divided by 500. Yes or no? V max 12 you are getting. How come? Just a moment. So I am getting 14 divided by 500. So 0.028 I am getting. Yes, I have got this value. Try it out one more time. So in this worked example I have given another thing. Yes. Good. So now you got it. So V max is equal to 14. You got it now? Yes, Piali. Good. So so V max is equal to 14. Correct. So your E by V max, it is equal to K cat. So your K cat in the question it is 500. So that is equal to 14 by E. So your E, it is equal to 14 divided by 500. So 0.028 micromole. Now, yes, you want to convert it into your nanomoles. So absolutely, it is going to be 28 nanomoles. 0.02. Correct. Got it everybody? So now you got the answer for this question. So everything is important, including the conversion. So don't underestimate the conversion. This conversion is what is going to seriously do the thing. Okay, right? So shall we make up a move towards the next problem? Okay, listen carefully. The dissociation constant Kd, it is 10 to the power minus 7 m. The concentration of the ligand that is required for occupying 10% of the receptor? What it is going to be is the question. Done? Slowly we can do it, don't worry. %10% of the receptor. Yes, ma'am. Shall we do it? See here, you know that this ligand is going to combine with the receptor to form the ligand receptor complex. So what is going to be the association constant? Product by the reactant. Yes, Kunal. So if it is a dissociation constant, it should be reactant by the product. Okay. So now they have given the Kd value. This value is known. Okay. Now Lr, it is going to be 10%. So what should be your reactant? It is going to be your 90%. Got it? Yes. So Lr is going to be, the product is just 10% it is occupied. That means 90% is free. So it is 0.9. This you take it as 1. So you don't know L. That is what is the question. So L is equal to Kd into Lr divided by R. So what is this fellow Kd? Kd is 0.1. 10%. 10 by 100. Right. So it is going to be 0.1. Into 10 to the power 7 is the Lr. Divided by R. What is R? 0.9. Okay, so R is going to be 0.9. So what should be the answer? 10 to the power minus 8. Now you got it? So you have to carefully see whether they have asked the association constant. Yeah, Kunal, you can do that definitely. And the dissociation constant. Okay, right. So here it is just a 10% of binding. So you can just multiply your 0.1 into your 10 power 7. So you will get 10 power minus 8. But just for those who are reading it for the first time, I just wanted to teach them like how it has happened. Got it? Yes? Okay. So see, the molarity of water in water, ethanol mixture, 15:18. This is water, this is ethanol. What is the molarity? This question we could have done for DBT, I guess. Done or what? Yeah, Kunal, I'll wait. Good. Everybody else? I'll tell you the answer. No, I'll tell you. Wait. I'll tell you. Everybody got the answer? Yeah, come on. Right. It is 8.33, so they have rounded off to 8.5. Okay, so you're right only. Right. So, yes, Piali. Correct, Piali. You are right. So, good. So, molarity means the number of moles of the solute per liter of solution. So, it is telling us the weight by the molecular mass. Okay, so weight by the molecular mass into the volume. Okay, so 1000 divided by the volume. So, this is what we generally use. So, it is 15 ml, so we take it to be 15 gram, and this molecular mass is 80. So, volume is just 100 ml. By percentage means it is 100 ml you take. So, it is going to be 15 original weight by molecular weight into 1000 by given volume is 100. Right. So, it is going to be 15 by 18. So, it is going to be 8.33 moles. Got it? Yes. So, the nearby answer is 8.5. So, you can go with this option. Got it, everybody in the class? Yes? Okay, fantastic. So, now it is clear, no? So, how to calculate these things? Right. Fine. Alright, so this is for your gate. So, maybe here you don't need this. Okay. And this is what is called as HH equation. Your pH is equal to pKa plus log of base by acid. Okay, this is also another important formula to be noted. Okay, so enzyme catalyzed biochemical reactions by means of which of the following? By sequestering the products, by decreasing this delta G, by increasing the delta G, by stabilizing the transition state. Which is holding correct for this question? Yes. Enzymes, how do they catalyze the reaction? Where do they act? They act to stabilize the transition state. Okay, so that is where the enzymes will act. This is the transition state. This is going to be the transition state. It is going to act at the transition state. Okay, so how it is acting? How it is acting by making them to the transition state? It is not by decreasing, but it is by the binding energy. Okay, it is not decreasing your delta G. But I agree, delta G is decreased. How? By means of the energy released by the binding energy. See, if you have an enzyme and the substrate, if they are binding, they are going to release a lot of energy. This energy, due to the interaction between your enzyme and the substrate, and energy is released, that is what is called as binding energy. That energy is going to reduce your this thing, but your enzyme, it is catalyzing by, this is the effect. Okay, so you understood, this is not the cause. They are asking the reason or the cause. This is going to be the effect. Understood? So who is causing that? It is because of the transition state. So now everybody understood this question. What is the difference between the cause and the cause and the reaction? Yes. So it is going to be stabilizing the transition state of the reaction. Understood, everybody? So now it is clear. No more doubts on this, I guess. Yes. Okay. Fantastic. So they have a binding energy at the transition state. See, at the transition state only it is decreasing. This is how your enzymes, they are catalyzing. Alright, so we are towards the end. So I had a few questions to discuss with you. Maybe in the next class we will do that. Okay, so last year we had a very good result, and definitely this upcoming year also we are foreseeing many people to qualify the examination. Yes, so if at all you have not yet subscribed to us at Unacademy, you can use my code Saranya Live and take up the subscription. As of now, an offer is going on that is giving you 20% off on the total fee. Just now I am starting a new batch. Okay, yes, so this is for your biochemistry. So don't miss out to enroll yourself for the program and get the edge of the preparation. Alright, yes everybody, so any doubts? So today we did a lot of numericals starting from evolution, molecular biology, biochemistry and much we did. Yes, okay, so I hope that this is all clear to you. So seriously, I'll meet you all with another interesting session. Take care till we meet. Yes, seriously, the summer is taking much. So have plenty of water, stay hydrated. Yes, see to your health. Your exam is chasing, your exam is very nearby, but your health is important. So please do take care of your health as well. Okay, everybody, bye bye. I'm signing off. I'll see you soon. Another interesting session. Take care till we meet. Bye bye. Thank you all. Bye bye.